Hi all, welcome back to our YouTube channel Code with Honey. Today we are going to solve August day 20th challenge, which is count square submatrix with all ones. So they'll be giving us a matrix of ones and zeros. We have to return how many square submatrices have all ones. So in the example, if you see the matrix, so square submatrices means so n should have the same value. So either it can be side 1, or it can be 1 cross 1, 2 cross 2, 3 cross 3, 4 cross 4, something like that. So if you take any values in an 2D array, that will have, if it is 1, that contributes to 1, right? So if we have 4 uh, values like this, 2D 2 cross 2, which is consist of full ones, then that contributes to 1 square. Okay, so if it is 3 like this, 3 cross 3, which is consist full 1, that contributes to 1 3 cross 3, as well as 9 ones, and 4 2 cross 2. So like this we have to add some all the number of squares, and we have to return the total number of squares submatrices present in a given matrix. So here if you see 10 ones were present, so that contributes to side 1. As we discussed, 4 2 cross 2 submatrices were there, and 1 3 cross 3 submatrices were there. Okay, now just take a look how we are going to figure it out and how we'll be counting those values. I have taken this as an example. Okay, so now how we are going to add this. So first let's see, this one, if you take at any I equal to 0 or j equal to 0, there was not any previous 1 or 2. So if you see here, even though this j equals to 0, right? So this can't be a square. This will be 1 cross 2. So 2 cross 1 matrices, right? So we want 2 cross 2. So if I equal to 0 or j equal to 0, it can't form a 2 cross 2 matrices, but it can form only 1 cross 1 matrices. So 1 cross 1 matrices is nothing but if the whatever the value that is exist, if it is 1, that will count to the 1 square. If not, it will be 0. So for I equal to 0 or j equal to 0, we won't do anything. We'll be just adding whatever the matrix value that they have given, right? Okay, now so when I and j are not equals to 0, which means we know that can form 2 cross 2, or it can be formed 3 cross 3 matrices, because if you see here now, it has previous, left, up, and diagonal. So now you see if this value is 0. Okay, now let's assume this value is 0. So it can't form 2 cross 2 matrix, right? Because this is 0. But it can form only, so among this, whatever the, if the current value is 1, and whatever the minimum among all this, okay, because this, see in this the minimum is 0, I minus 1 of j, I minus 1, j minus 1, and I of j minus 1. Among this, whatever the minimum value is there, that you take and add it to the array. In this case, if it is 0, what will be our answer? 0 plus 1 will be 1. That too if the current value is 0. If the current value is 1, if the current value itself 0, So this itself won't contribute anything. You just add the whatever the corresponding matrix value. Got it? Now let's assume this is also 1 and this is also 1 for now. So now what will be our answer? Now we have 3 ones already. We have added those, okay, to the DP. This is a DP array. Okay, let me add this is a DP array, and this is the matrix that they have given. Got it? Okay. Now we have already 1 1 1. So now by adding this one, we know it can form either 2 cross 2 or 3 cross 3 submatrices. So what we will be doing? Now we'll be checking. Okay, previous what is the minimum? Everything was 1 1 1. So 1 plus 1 now it contributes to 2, which means it this itself forms 1 square submatrices. Among with this it can form 2 cross 2 uh, submatrix. So it contributes to 2. Okay, now when the matrix gets increases, the same. Let's have here 0 and 1. Okay, now this is equals to 0 through, right? So we will just add whatever the matrix value, which is 0. Now here if this value is 1, so we will be checking what is the minimum. So this is 1 and this is 1, but this is not 1, right? So what it can minimum among this is 0. So 0 plus 1, so it can form only with this value what you can form only 1 submatrix, 1 square submatrix. So it is 1. But by any chance if was 1, now this would have been 1. Now what will be the answer for this? So here what is the minimum? This with this value this can form 2 cross 2, but with this it can't form 3 cross 3 because it is not square. Okay, only I is having 3 values and j is having 2 values, so 2 cross 3. So still we'll be checking the minimum. Okay, it can form 1, it also has 1, it also has 1. Among this what is the minimum? 1. So 1 plus 1, which is 2. So this also can contribute to 2 cross 2 like this. Okay, so this also can contribute to this 2 cross 2 and this can contribute to this 2 cross 2. So now we have the value. So now when on down, if you have 1 1 1 like this, which means so for this position here I equals to 0, j equals to 0. So whatever the matrix value we will be adding, because if I equals to 0 or j equals to 0, it can't be contributes to anything other than 1 square submatrix. So when it comes here, okay, it can contribute to either 2 or 3. Okay, but as per we see here what all, so 2 1 1 are there. Among this what is the minimum? 1. So this can contribute only to 2 square submatrix, right? It can't form 3 with this value alone. So what we will be doing will be adding 2. Now when it comes here, so if these 2 were there, then we know also if here it was 1, then we can add. Here if it was 0, then obviously it will be 0. We won't be doing anything. Here since it was 1, so here you would see 2 2 2, which means all these were 1. Only when these values were 1, only here we'll be getting 2 2 2, right? So then among this, we for to fill this value we'll be checking horizontal, vertical and diagonal. So then we'll know what is the minimum value. 2. So 2 plus 1 will be getting 3. So here why it is getting 3 means it contributes to 2D. Okay, it contributes as well as 3D, sorry, 3 square submatrix. It contributes to 2 square submatrix. It contributes to 1 square submatrix. So by any chance, if somewhere let's assume here it was 0. Okay, in that case what it would have happened here, so now here it was 0, then this 2 it wouldn't have formed, right? Now it would have got updated with 1, because only one to this it can't form 2, it would have formed only 1. Okay, now we know, since here it is 1, among this what is the minimum? 1. So with this you can form, with this one you can form 2 cross 2 as well as 1 cross 1. So here this value would have updated to 2. So basically, so yeah, like this only we'll be having the previous 3 states. What is the previous vertical value, horizontal value and the diagonal value. By that we know among the minimum, and if the corresponding matrix value of that ij is 1, we can add the minimum of this plus 1 will give you the number of squares submatrices. So at the end, what we'll be doing, we'll be keep on adding all these values, will give you total number of square submatrices. Okay, now let's look into the solution. So this is the solution. So here the same thing we would have done, we would have the dpra, which is n1 is nothing but length of row, n is column. Okay, so we are basically forming m cross n dpra. So it's not like they have told it will be n square dpra, there will be difference of length m cross m. Yeah. So we'll be traversing through each values. If the matrix, or if it is ij, or the matrix value is 0, you should have whatever the matrix value and you're updating the dpra. If not, you will be checking previous vertical value and the diagonal value, and we are doing plus 1. So by then, and instead of traversing at the end and you are keep on adding it to the resultant value, we are just at the end, this dp of ij never going to be changed, so we are just, instead of traversing one more time, ij will be adding that to the sum of square submatrices and we are returning. Now for this example, initially let's fill the dpra with the solution that we have used. So the same, initially I equals to 0, j equals to 0, matrix of ij is 0. Okay, so what we will be doing, whatever the matrix of ij, you fill that. Okay, now second, so we will be filling all this, because either it will be I equal to 0 or j equal to 0 or matrix of, so this we won't be checking the previous horizontal or vertical values. So now for this particular value, see what is the, this is 1, so we will be checking I minus dp of I minus this, what is the minimum? 0. So we'll be just updating 0 plus 1 is 1, because it can form only 1 d array, it can't form 2 d array, right? Now this can form 2 d array as well as 1. So what is the minimum for here? If you see 1 1 1 already we have, so 1 plus 1 will be giving us 2. Okay, in this now this is 1, so the minimum is 1, so 1 plus 1 also gives us 2. Now here if it goes for this 1, This is not matrix of I j is not equals to 0, so it's not either I equal to 0 or j equal to 0, right? So now we'll be checking these three values. Among this, minimum is 0, so which means it can't form 2, so it can just form only one D array, sorry, one square submatrix. So we'll be adding it to the 1. So now for this we know it can form 2 as well as 1 square submatrix. Now among this, minimum is 1, so 1 plus 1 will be giving us 2, so it can form 1 as well as 2. So when this 1 comes, you see, already 2 submatrices we can form. Already these three are forming 2 cross 2. Now we know this can contribute to 3 cross 3 as well. So minimum is 2. 2 plus 1 will give us 3. So sum of all this will be keep on adding it to the square of submatrices, right? So 1 plus 1 plus 1 plus 15. As a result, we'll be getting 15 and we will be returning. Yeah. So to optimize further what we can do, so basically we need a I minus 1 array. It's not like you always need um, I minus 1 and the current array. It's not like you always need full dp array. So we can just use, instead of for dp of I minus 1, we can use, maybe we can have we'll be having, instead of dp, let's have previous engine 1. Okay, so this was a previous. So here current dp will you have it as a current. This is also current. Here you will have previous. Okay, previous and current. So dp of I minus 1 is nothing but previous. I minus 1 is previous, right? So yeah, and previous, this is dp of I is current. So whenever you are adding, you just add current of, okay, whenever you are adding, you just add current of I of j to the submatrix, and once this j loop is terminated, you assign current equals to previous. By that you can reduce the time complexity, will be order of m cross n in both the cases. For the first approach, space complexity will be order of m cross n. Second approach, space complexity will be order of 2n, which is technically order of n. So yeah, uh, I hope you guys would have understood. If you have any questions or concern, please do leave a comment. And if you, I'll be providing these two solutions in the GitHub. You can go and check it out. If you do like my video, please do like, share, and subscribe, and share it with your friends. Thanks for watching.